It was September 1st, 1859. A British astronomer named Richard Carrington was observing sunspots through his telescope, sketching them onto paper as he usually did. Suddenly, a blinding white light flared across the sun's surface, a solar flare so powerful that Carrington himself was stunned. What followed was a cosmic wake-up call, the largest geomagnetic storm ever recorded on Earth. Within hours, the storm would send a barrage of solar plasma racing toward our planet at unimaginable speeds. The Carrington Event had begun. By the next day, chaos unfolded across the globe. Telegraph systems, the height of mid-19th century technology, went haywire. Operators reported sparks flying from their machines, some even catching fire. Messages were transmitted without power as geomagnetic currents flowed directly through the lines. Across the night skies, auroras lit up like a surreal light show, seen as far south as the Caribbean and as far north as Queensland, Australia. These lights weren't just beautiful, they were a dire warning. But back then, the world was mostly analog. Technology was limited. The damage was minimal compared to what we'd face today. Fast forward to the 21st century. Our reliance on technology is absolute. From satellites controlling GPS and weather forecasting to global financial networks handling trillions of dollars daily, our world runs on an invisible web of electricity and data. The power grid is the backbone of it all. A single day without power isn't just inconvenient, it's catastrophic. No water, no food supply chains, no internet, no healthcare systems functioning. Worse, satellites would be fried, taking out navigation, communication, and even national defense systems. To put it simply, our infrastructure isn't prepared. In 2012, a solar storm nearly as powerful as the Carrington Event narrowly missed Earth by just 9 days. According to NASA, had it hit, the damage could have cost the global economy upwards of $2 trillion in the first year alone, with recovery taking a decade. The 1859 event hit a relatively simple world. Telegraph lines were the cutting-edge tech of the time, and even they were overwhelmed. Imagine the same storm today. First, satellites would be among the first casualties. The charged particles from a coronal mass ejection could fry sensitive electronics, rendering GPS, internet satellites, and weather monitoring systems useless. Planes would lose navigation mid-flight. Grounded? Maybe. Chaotic? Absolutely. Next, the power grids. Transformers aren't built to handle geomagnetic surges of Carrington-level magnitude. The cascading failures would black out entire continents. Experts estimate that in regions like North America or Europe, it could take months, maybe even years, to restore full power. Banking systems would collapse. Stock markets would freeze. Emergency services would be overwhelmed. Hospitals, dependent on electronic equipment, would grind to a halt. It wouldn't just be inconvenient, it would be life-threatening. The irony is that we know how to prepare. Hardened transformers, better satellite shielding, and improved forecasting systems could reduce the risk. Yet, investments in solar storm resilience remain shockingly low. It's a disaster waiting to happen. The Carrington Event, while improbable, was inevitable, as is most things are in space. But compared to the other horrors in space, solar flares don't compare. At least there is a proven possibility we could survive another event. Most other equally mysterious and seemingly inevitable events are much, much scarier, much darker. Somewhere in the vastness of space, a black hole lurks, a gravitational monster so powerful not even light can escape its grasp. It's a cosmic trapdoor, warping the fabric of reality itself. Once something crosses its event horizon, it's gone. No second chances, no return. Black holes come in different sizes. Some, like stellar mass black holes, form when massive stars die, collapsing under their own gravity. Others, supermassive black holes, sit at the center of galaxies, weighing millions or even billions of times the mass of the sun. What's terrifying? We don't even fully understand how the supermassive ones form. And if our solar system drifted too close to one, at first, it wouldn't even look that threatening. Black holes don't suck things in. Their pull is like any other object's gravity. But once the distance closes, the danger becomes impossible to ignore. Tidal forces would rip planets apart. Earth itself would stretch, deform, and finally shred into nothingness. But it's not just proximity that makes black holes dangerous. They emit jets of high-energy radiation when consuming matter. These jets can span light years and sterilize anything in their path. If a supermassive black hole's jet were aimed at us, the Earth could be cooked alive, no warning, no escape. Worse still, some black holes might roam the galaxy. Rogue black holes, ejected from their galaxies or formed without a host, travel silently through space. They're invisible, untraceable, until their gravitational effects start tearing systems apart. We wouldn't even see it coming. A rogue black hole passing within even a few light years could disturb the Oort cloud, sending a rain of comets hurtling toward Earth. We'd be bombarded with icy missiles for centuries, all thanks to something we might never even detect. Then there's the theoretical horror, the primordial black hole, tiny ancient remnants from the Big Bang. If one of these were to wander into Earth's vicinity, it could tunnel through our planet, devouring matter with each pass until nothing remained. Black holes don't just reshape space, they rewrite the rules of physics. Time slows near their event horizons, meaning a spacecraft approaching one might seem frozen to an outside observer. For the crew aboard, though, they'd watch the universe's clock speed up, seeing stars and galaxies evolve in moments as they're pulled toward annihilation. In the end, or rather, in their center lies a singularity, a point of infinite density where space, time, and all understanding of the universe breaks down. What happens there? No one knows. Some theories suggest the singularity connects to another universe. Others think it might erase information altogether. Black hole is truly one of the most mysterious things our world has to offer us. Everything we know about them could just be stories. 66 million years ago, an asteroid roughly the size of Mount Everest slammed into what is now the Yucatan Peninsula. The impact unleashed the equivalent of billions of nuclear bombs, triggering tsunamis, wildfires, and an atmospheric blackout that choked the Earth for years. The dinosaurs, once the undisputed rulers of the planet, were gone in the blink of a geological eye. The event wasn't just a reset button for life, it was a sobering reminder of how fragile existence really is. What if that asteroid had been a little larger, or if its trajectory had been slightly different? The devastation could have wiped out not just the dinosaurs, but also the tiny mammals that eventually evolved into us. Earth has no special protection, no divine guarantee against such cosmic intrusions. It's all chance, a roll of celestial dice. Asteroids are just one piece of the puzzle. Comets, those icy wanderers from the far reaches of the solar system, can be just as deadly. Unlike asteroids, comets announce their approach with far less warning, their eccentric orbits bringing them into the inner solar system unpredictably. Halley's Comet, for example, returns every 76 years. But what if a new comet one with a long, uncharted orbit suddenly appeared? Comets travel faster than asteroids, and their icy cores can release gases and debris that expand their destructive reach. Then there are rogue planets. Picture an Earth-sized world ejected from its home star system, drifting silently through the void. These planetary nomads are gravitational wrecking balls. They don't need to collide to cause chaos. Their mere approach could pull Earth out of its stable orbit. Seasons would stretch and warp. Summers would become infernos, winters frozen wastelands. Worst case, the rogue planet flings Earth into deep space, where life as we know it would end in an eternal freeze. The terrifying part is how little control we have over these events. We might spot an asteroid decades in advance, but redirecting it? That's still largely theoretical. Projects like NASA's DART mission give us hope, but they're no match for larger, faster objects. Comets often come with weeks of warning, leaving humanity scrambling to watch from the sidelines as catastrophe unfolds. And rogue planets? We wouldn't even know they were coming until their gravitational pull started bending orbits in our solar system. By then, it would already be too late. The Earth's history is marked by impacts and disruptions, each one a cosmic coin toss that left us inexplicably on the lucky side. But the universe doesn't care about luck. It operates without intent, without malice in ways that can undo entire civilizations in an instant. We're passengers on a planet hurtling through a celestial minefield, hoping that nothing goes wrong. Because truly, there is nothing we can do.